Today we're going to talk about conditional statements right here, conditional statements. And when you look at these notes, there are lots of different kinds of things that we could have here. They fall under all of these kinds of different ones. We've got these fancy names down here, and we'll talk about all of these things. But for right now, we're going to stick with the if-then statements when we talk about conditional statements. So when we talk about a conditional statement, all we're saying is it is a statement in if-then form. Now, this might not seem much like math to you, especially geometry, but we'll see how this all kind of comes into play here soon enough. So when we talk about this if-then form, and we're talking about a statement in that form, the hypothesis is the if part, and the conclusion is the then part. For example, right down here, if a polygon has 8 sides, then it is an octagon. This part here, the if part, that is what we call the hypothesis. And it is an octagon, that's the then part, that's what we call the conclusion. Now, a lot of what we're going to be practicing today is going through putting things into if-then form. So I have these statements, and then we're just going to practice doing this in writing these in if-then form. So a right angle is an angle that measures exactly 90 degrees. I would write that as if an angle is a right angle, then it measures exactly 90 degrees. And that's taking that same sentence, just putting it into if-then form. And this if-then form is really important for us in math because it tells us what we're given. And this is what we try to prove a lot of times, or it's how we define things or how we know about making these statements. So we know something, therefore we can conclude something else. That's why we do this. It's for the logical side of math. And we'll see this. Most of the things I write this year, you'll notice definitions and theorems and all of those kinds of things will all be written in this if-then form. So we use it a lot with math stuff. It doesn't have to be. We have these other sentences down here. And I would encourage you here for a moment to pause this and then try them out, and then come back and see how you did. Now that you've come back, checking to see how you did on all of these, I bring an umbrella when it's raining. There's a couple of ways to go about doing this. Um, Probably the best way to go about this is just to kind of go in the same order here. If I bring my umbrella, then it is raining. Now, this third one, Suzanne eats a snack if she is hungry. I know I said up here I keep it just in the same order. If I bring my umbrella, then it is raining. But here, since it already has an if part, that's what I want to keep as the if part. So I'm going to say if. Now I'm still going to put the Suzanne part of this. So I'm going to put if Suzanne is hungry, Then she eats a snack. And that's how we go about writing conditional statements. That's going to be most of today, but there is something else, and I'm going to show you that here in just a second. Now, the other part of the notes aren't included in here, so you're going to have to put these on a separate piece of paper. And it's really just kind of an example here, or kind of, it's a definition. We'll talk about a counter example. And a counter example is just an example that shows a statement is false. So any kind of statement, any kind of thing that will show us the statement is false. Couple of examples here. If, now I'm going to go with one that's pretty straightforward. If it is cloudy, then it is raining. Now, you can give me all sorts of examples that we see all the time where it's cloudy and no rain. We see those days all the time. That's a counterexample of saying that statement's false. So this is a counterexample. Now, another one, this is more of a mathy one. If x squared equals 4, then x equals -2. Now, equals 2. Let's go with +2 there. And what you would say is like, oh, you might look at that and say, oh, well, yeah, x equals 2. X squared is 4. X has to equal 2 because 2 times 2 is 4. But the counter example of that is to say that x is equal to -2. So you have to list both of those when you're talking about something like this. So the statement will say, oh, if x squared equals 4, then x equals 2. That's false. The counter example is x equals -2. So all we're looking for is something that shows that a statement is false.